Welcome to our lesson on implementing security controls.
Today, we will cover various crucial aspects, including addressing security risks, applying security during the build process, using anti-tampering techniques, and securely integrating components.
We'll also explore the secure reuse of third-party code or libraries and the significance of system-of-systems integration. Let's start with understanding security controls. Security controls are measures taken to detect, prevent, and mitigate risks associated with threats against specific targets, such as applications or information flows.
They ensure that software behaves as intended, despite any environmental interferences.
Next, let's discuss addressing security risks. Once risks are identified, there are four primary options for dealing with them. First, remediation, which involves fixing the problem by understanding the root cause and correcting the issue. Remediation is the preferred option as it solves the problem irrespective of external changes.
Second, mitigation, which reduces the risk associated with an event.
For example, adding encryption to clear text protocols to remove the clear text disclosure issue.
Third, transference, which involves shifting the risk to another party, such as through insurance or warnings to users. An example is financial fraud associated with online credit cards, where the bank card issuer covers the fraud loss.
Lastly, acceptance, which involves accepting the risk and its consequences.
This is often a last resort and should be chosen with a full understanding of the potential costs.
Now, let's talk about implementing security controls.
Basic security controls include watchdogs, file integrity monitoring, and ensuring proper compilation and linking settings. Watchdogs are routines that check if processes are functioning as expected. An example is the time-to-live (TTL) component in network protocols. File integrity monitoring ensures that files have not been tampered with by comparing their hash values to stored values. Applying security via the build environment is essential. A secure development lifecycle, or SDL, involves clearly defined processes and procedures, proper configuration of tools such as compilers and linkers, and using safe libraries to minimize common errors. Integrated development environments, or IDEs, streamline various aspects of development, making the workflow more efficient and secure. Anti-tampering techniques are crucial for making it difficult for attackers to modify code and pass it off as genuine. Code signing involves applying a digital signature to code, allowing end users to verify its integrity and source. Code obfuscation makes it challenging for attackers to understand or alter the code effectively. Defensive coding techniques involve both declarative and programmatic security. Declarative security is managed by operational personnel and is not embedded in the code, making it more flexible. Programmatic security, on the other hand, is embedded in the code, allowing for fine-grained control but reducing portability. Bootstrapping ensures secure startup processes to prevent malicious software from interrupting the boot sequence. Cryptographic agility involves managing cryptographic functions via configuration files, allowing for easy updates and compliance with international regulations. Handling configuration parameters properly is crucial, as they can alter the behavior of an application. Securing these parameters involves protecting the configuration files and ensuring they are not modified by unauthorized sources. Effective memory management is essential for security, involving both the operating system and the application. Type-safe practices help prevent memory-related errors by ensuring that data types are used correctly. System-of-systems integration involves integrating different subsystems into a whole, ensuring that data crossing trust boundaries is revalidated and secure. Secure reuse of third-party code or libraries can enhance efficiency and security if properly managed through software composition analysis tools. In conclusion, we have covered the importance of implementing security controls, methods for addressing security risks, the application of security during the build process, anti-tampering techniques, and secure integration of components. We also discussed defensive coding techniques and the significance of secure reuse of third-party code or libraries. Thank you for watching. Stay secure.